Okay, so as far as number representations go, the first two are ones that you guys have probably used before, and that is inequality notation and graphical notation. And so these are the two that you've probably done in algebra. The other one, and it's the one that we will probably use the most often here, so it'll very likely be new to you guys, is called interval notation. Okay, so make sure as I go through this that you understand how these are related and how you can convert back and forth between the different forms. Okay. So the inequality notation is to simply say something like this: x is greater than or equal to 1. Right? So what you guys have probably been familiar with is you could sketch a graph of this on a number line, right? If you sketch your number line, you identify your critical point. In this particular type of inequality, you only have one critical point. So we label that point 1. And then you identify, are we selecting all of the values that are to the right or to the left of this point? Greater than is to the right, less than is to the left. We want all the x's that are greater than or equal to 1, so are we going to the right or to the left? Okay, so we're looking at everything to the right. So this is the set. And then you guys also, the last thing is you determine whether that critical point is included or not included. Okay? Since it has an equal to, that means we're dealing with an included endpoint or critical point. And so you guys probably represented that with a solid dot, right? Okay. So you guys used solid dots and open circles to represent points on a number line. We're going to change that slightly. Instead of solid dots, what we're going to use are square brackets. And instead of open circles, we're going to use parentheses. Okay, so they still mean inclusion of that critical point and exclusion. Okay, so the solution or the critical points are either included or excluded based on that grouping symbol. Okay, so instead of a dot here, we're going to use a bracket, and the bracket's going to open in the direction that the graph opens. So there should never be any confusion. Okay, I'm sure that either you guys have done it or you've seen somebody do a half open circle, so you can maybe make the argument that you meant to shade it in all the way if you weren't sure. Okay, so there should be no confusion. A square bracket opening in the direction that the graph opens is your graphical notation. Right now, the interval notation is always going to be of the form a lower bound, comma, an upper bound. That's always how it's going to be set up. So you have a lower bound, comma, upper bound. And then you'll have some kind of grouping symbols on the outside, either parentheses or brackets. Okay. So when you look at this, and it's usually easiest to find the interval notation by looking at the graph. What is the lower bound? Lower bound means furthest to the left. So what value is furthest to the left on this solution interval? 1, right? So that's your lower bound, comma. And what value is furthest to the right? It extends all the way to infinity, so that would be our upper bound. Again, when you type this in, you'll identify it as INF. Okay, now, you can never actually include infinity, right? Because there's always something that goes beyond it. So you'll never include it. It's always excluded. So there's always going to be a parentheses at any infinity that you put in an interval notation. Now, what about the 1? Is the 1 included in the set or excluded? Has the equal to, so it's included, so you'll use a bracket. So this is the interval notation for this set of numbers. All right, anytime you have an infinity in the interval notation, it's called an unbounded interval. Okay, so you could have unbounded to the right, you could have unbounded to the left. If you're dealing with one that is located between two values, so let's say we take -2 to 5. Okay, so x is greater than or equal to -2 but less than 5. Okay, so that's the inequality notation. Okay, on each of these, it is possible to represent these on the computer as well. If you were typing x is greater than or equal to 1, you would type x greater than followed by equal and then a 1. And so you can still do one of those inequalities with it that is an inclusive inequality. And just by putting two separate symbols. Always put the inequality symbol first and the equal symbol second. And anytime you're labeling these, if it's an unbounded interval, always write x first. Doesn't matter whether the value is a lower or upper bound, always write your x first. Anytime you're writing the inequalities that are bounded, however, always write the lower value first. Okay? So here it should go in the order that it appears on a number line. So -2 comes before 5. Okay, so if we look at our number line here, we want to sketch this graph. We plot our two critical points, so -2 and 5. We want all the values that are greater than or equal to -2. So will it be a parentheses or a bracket? Bracket, and it's going to open to the greater than side, right? X is greater than that. But here x is less than 5. Does it include 5? No. So less than opens back to the left. So this would be the graphical notation. And if you want, you can shade or you can darken in the line between them, but you don't even really need to. As long as you have the symbols opening in the correct direction, it indicates what the graph looks like. Okay. And so our interval notation, again, starts with our lower bound, followed by our upper bound, and then the correct grouping symbols based on inclusion or exclusion. So -2 has the equals, so it's a bracket. 5 is not, so it's a parentheses. Okay. The last type of interval that you might see, or inequality that you might see, is a compound or inequality. So this is a compound and inequality, where something falls in between. But you might have something where it says x is less than 3, or x is greater than or equal to 10. And so this is a compound or inequality. In this particular case, when you look at the graph, again, we sketch what we have. We're dealing with two separate unbounded intervals here. So you're actually going to have an unbounded interval to the left and to the right. So you need to indicate those individually. So we write our numbers in the order that they appear. So plot the 3, plot the 10. And then identify what grouping symbol accommodates each, or accompanies each. So here x is less than 3. So is 3 included or excluded? Excluded, so that means it's a parentheses. And if x is less than 3, less than is to the left. So that would be opening to the left. There's our first unbounded interval. The second one, x is greater than or equal to 10. So is that going to be a parentheses or bracket at 10? Bracket, and it opens to the right. It's greater than. And so this would be your graphical notation for that inequality. Okay, and then finally, if you have, so this interval up here is a bounded interval. It has a specific beginning and end that are numerical values, okay, or real numbers. It doesn't matter that it never actually reaches 5. It only matters that there are specific values as your lower and upper bound. Okay, but if you have two unbounded intervals, the way that you express that is you write each interval individually, starting with the lowest. So what's the furthest to the left value in this interval? -infinity. So we start with -inf, and it goes all the way up to 3. There's our upper bound. The infinities will always have parentheses. Here we see that the 3 is not included, so it's a parentheses. Our second interval, the lower, or the furthest to the left, or the lower bound of our second interval is 10. The upper bound is infinity. Again, always a parentheses at infinity. Is the 10 included in our set? It has the equal to, so that is included. And anytime you're dealing with multiple intervals for a solution set, you're going to put a U in between them. The U represents union of sets. It just means that you have these multiple sets. And I expect to see a U when you enter the interval notation as well.